Assignment 3, Example 1. Let V be the vector space of the functions from R into R. Show that fx is equal to e the power x, gx sin x, hx x square. All these functions are linearly independent. Very easy. Just last time we have done just similar example. We have already done. Let me revise this again. Okay, the functions are alpha e the power x plus beta sine x plus gamma x square is equal to 0, right? For all x belonging to R, marking this as 1. Differentiating this one 2 times because I'm having 3 functions here. So this is alpha e the power x first. Just rewrite the equation first. Okay, differentiating this first. This is alpha e the power x plus beta cos of x plus this is 2 gamma x. And then again differentiating this thing now. So this is alpha e the power x minus beta sine of x plus 2 gamma equal to 0. Right? Now taking the coefficient matrix for this system. So we get e the power x, e the power x, e the power x. So cute. And then it is sine of x, cos of x, negative sine x. And then I'm having x square, 2x, and then 2. Right? Okay. Now just take the determinant. And this determinant comes out to be, please check that. This is negative 2 e the power x, which is of course non-zero. So the system 2 has trivial solution. Thus alpha equal to beta equal to gamma is 0. So f, g, h, all these functions are linearly independent. Pretty different example. Example 2. Let V be the vector space of continuous functions from negative 1 to 1, this open interval, into R. Show that f, g belongs to V are linearly independent, where functions are given to be x and mod of x. Mod of x. Now for mod of x, you need 2 values, either negative or positive. So you have to define both the values for this mod of x, right? So let's take 2 values of x for this mod. Let me take x to be equal to, alright, I'm taking 1 by 2. And second value, I'm taking negative 1 by 2. Of course, if you take 2, then you take the other one as negative 2, depending upon your choice. Alright, so just taking this as x, and I'm taking 2 scalars, alpha and beta. So this is alpha x plus beta mod x equal to 0. So first put the value of x is as half 1 by 2 in 1, and then put the value x equal to negative 1 by 2 in 1. Right, put these 2 values. So if I first put 1 by 2 in 1, I get alpha by 2 plus beta by 2. Alright. Now putting the negative 1 by 2, I will get negative alpha by 2. Sorry. Put x to be as negative 1 by 2. Yes. And then I'm having this as mod of, which is mod of minus 1 by 2 is again 1 by 2. So this is beta by 2. Which implies I can also write it as alpha by 2 negative beta by 2 is equal to 0. Right? Now writing the coefficient matrix. So this is 1 by 2. This is 1 by 2. This is 1 by 2, and this is negative 1 by 2. You can also end up here For that you have 1 by 2 and negative 1 by 2, 1 by 2 and positive 1 by 2 coefficient matrix, right? You can take any of these two cases. So A is equal to this, the coefficient matrix. What is the determinant of A? This is negative 1 by 4, negative 1 by 4, which is minus 2 by 4, which is minus 1 by 2, which is non-zero. Right? You can also change these equations as alpha plus beta equal to 0, and here it is, from here this is alpha minus beta equal to 0. You can also take the equations as this, right? That doesn't matter. Now the system 2 has only trivial solution because the determinant comes out to be 0, which means the system has only trivial solution, that is alpha equal to beta equal to 0. So the functions are linearly independent. Third example, show that the function sine square x, cos of 2x and 1 are linearly dependent. Wow, now is the case for the linearly dependent over open interval 0 to infinity. So let me guess. Let me take the scalars to be again alpha, beta, gamma. So I am taking, so this is alpha sine square x plus beta cos of 2x plus gamma 1 equal to 0 for all x belonging to 0 to infinity. Mark this as 1 and differentiate 1 with respect to x 2 times. So I am differentiating alpha sine square x plus beta cos of 2x plus gamma, okay, just write only gamma, equal to 0. So this is 2 alpha sine x cos x. This is nothing but sine of 2x. We know that 2 sine x cos x is sine of 2x, the identity. So I'm writing it as sine of 2x negative 2 beta sine of 2x. This is 0, right? Again differentiating this as 2 alpha cos of 2x. So this is negative 2 beta cos of 2x but with 2. So this is equal to 0. So the coefficient matrix comes out to be, this is sine square x and this is sine of 2x and then 2 cos of 2x. Just take the coefficients. So this is cos of 2x negative 2 sine of 2x and then negative 4 cos of 2x. And then I'm having 1, 0, 0. Right? Find out the determinant for this matrix and that determinant comes out to be, yes, negative 4 sine of 2x cos of 2x, wait, 4 sine of 2x cos of 2x cancelled. This is equal to 0. Solve the determinant, you will get this finally, and then they cancel out each other. You get that determinant A is equal to 0. And what do you mean by determinant A to be equal to 0? The system 2 has non-trivial solutions, and non-trivial solution means all the alpha i's, all the scalars are non-zero. Very good. So alpha, beta, gamma are not all 0. Not all 0. Hence, these functions are linearly dependent. Right? So, thank you so much. God bless you. We meet in the next video. Thank you.